So, good morning, everyone. I am Dr. Neeraj Gupta. Let's start with the whatever we left at that very time. So, we were discussing the classification of the faults. And now here we have the different kinds of faults, various ground and the phase faults. Now, in this case, you will see this is the line to ground fault, and this is the fault resistance. Then we have a line to line fault between the two lines. After that, we have the line to ground fault. That is, two lines are connected along with the ground. And after that, we have the triple line fault. And next is the line to triple line to ground fault. So these are the various kinds of faults. So when the fault takes place, how we know that the fault has occurred? So there must be something. So a fault will increase the current. That is, it started with the build-up of the current. So fault started with the build-up of current, and along with that, there is fall in the voltage throughout the power system. So there is fall in the voltage throughout the power system. However, if it is a metallic fault, if the fault is metallic fault that we have discussed in the previous lecture, if the fault is metallic fault, in that very case, the voltage at the fault location is 0. If it is metallic fault, then the voltage at the fault location is 0, and the voltage at the terminals of the generator will also drop throughout drastically because of the fault. However, if the source is ideal, which means that the inductance of that particular source is 0, then in that very case, there is no drop in the voltage at the generator terminals if the source is ideal. Normally, we will have the relay is actually very much away from the fault location. So as seen from the relay location, a fault is actually characterized by the build up of the current. It is characterized by the build up of the current and to a certain extent collapse of the voltage. So whenever the fault occurs, so these two characteristics we have to see the value of the current, we have to see the value of the voltage. So if there is the buildup of the current and the collapse of the voltage, then we can say that fault has occurred. Now let us here consider the radial power system where the fault is at the remote end of the line. So in this case, you will see that when the fault occurs, then in that very case, there is the reduction of ZL, that is, impedance will be reduced because of the fault, and there is the increase in the current IA because of the reduction in the impedance. And when the impedance is reduced, in that very case, this terminal, there is the increase in this value. If we are considering only phase A, so with the increase in IA, this component will increase, and as a result, there is the fall in the voltage. So in this case, with the fault, there is the increase in the current and there is the fall in the voltage whenever the fault occurs at the remote end of the line, as you have seen. In this diagram, you will see that we have different components. We have the source, Then this is the source impedance. Now we have the location of the relay, that is there CT is used at that particular point and the current is measured. Then PT is used, voltage is measured. This is the relay, and this goes to the circuit breaker. So from this we will see that at the remote end of the line there is because of the decrease in the ZL, there is increase in IA, and because of the increase in IA there is the reduction in VA if we are considering only the phase A. So from this we observe that the voltage at the relay location during the fault is less in magnitude. From this we will see that the voltage is less in magnitude than during the pre-fault condition, and it also lags the pre-fault voltage because of the increase in this component, that it lags because of the increase in this component VA if we are considering only the phase A. Now figure here shows the distortion of voltage during all the 11 shunt faults, that is distortion of voltage during all shunt faults. In this case we will see that in this we have the line to line fault, so triple line fault. So in this case there is the distortion in the voltage, that is voltage is reduced in all the cases. And then we have second one, that we have the in this case line to ground. So these are actually the voltages at the relay location during the various faults, that is whatever the voltage the relay sees during the various kinds of faults, that is voltage at relay location. So from this you will see you have we here the fault is in two phases A and B, so these are reduced, however the C is intact. Now we have the line to ground fault, that is in the phase A and C. Then we have B and C. Now we have a fault from, it is actually the line to ground faults. In this case you will see that the voltage of VA is reduced, that is it is actually the line to ground fault, so the voltage is reduced in that very case, and this was the line to ground fault. So in this case also the voltage at the B is reduced at the relay location. Then we have C, it is also reduced at the relay location. Then in that very case we have three cases in this case. So here we have line to ground fault, and in all the cases we will see this. So this is actually the distortion of the voltage during all the shunt faults, or we can say that this is the voltage at the relay location. Now we'll discuss the series fault. We already discussed the shunt faults. Now what are series faults? So these are nothing but the breakdown of the path of the current. Let us suppose that some current is flowing in the wire, and if there is the breakdown in the path of the current, initially let us suppose that initially the current which was flowing in is I, it has some value. Now when the series fault occurs, so there is the breakdown of path of the current. It means that in this case the current I equals to 0. So this kind of fault. These kind of faults are known as the this series faults. Such type of faults do not result in catastrophe except that when the broken conductor touches the ground. Let us suppose that this broken conductor touches the ground. Otherwise, they are not so harmful. So this is the case when the broken conductor touches the ground. Then in that very case, it is harmful. So, however, in practice, it is observed that most of the this open conductor faults, that is, you can say that most of the series faults, these are also known as the open conductor faults. So most of the series faults are the open conductor faults, sooner or the later develop into the short circuit fault. So most of the open conductor faults will sooner or later will develop into the short circuit faults that we have discussed. However, there are some instances where the open circuit it have very dangerous consequences, like when secondary circuit of the current transformer, the secondary circuit of current transformer, the secondary circuit of current transformer and the field of DC machine, it is open circuited. So it has the dangerous consequences when the secondary circuit of CT and the field of the DC machine is open circuited. So we can discuss that in the lecture, in the subsequent lectures, that how is it so. Now let us discuss the abnormal operating condition. We have discussed the faults. So there is very little, that is crisp boundary between the faulty system and abnormal conditions. However, if you see that certain operating conditions which are inherent within the power system, which are definitely not normal, but these are not the faults either. So that is, there are some operations which are not normal. Obviously, it is in power system. And these are not faults either. So what are these? First one is magnetizing inrush of transformer. Second one is starting conduction of induction motor. And third one is the conditions during the power swing. Being the electrical background, you already know the power swing. So the question arises, should the protective relay trip during the abnormal condition? That is, should the protective relay trip during the abnormal conditions? So this is the question. The answer is the protective relay should respond to abnormal operating conditions with careful consideration. With careful consideration. However, the magnitude of these current is such that the magnitude of these current in case, suppose, inrush current of the transformer. So the magnitude of that is such that it will qualify, it is such that it may qualify as the faults. The magnitude is such that it may qualify as fault. However, there is no need to provide protection. It may qualify as fault, but there is no need to provide protection in that very case. So, even though it may qualify as a fault current, but there is no need to provide protection. So protective system must be able to discriminate between the protective system must discriminate between the abnormal operating condition and the fault. So protective system it must discriminate between the abnormal operating conditions and the fault. So from the above discussion, you have to answer these two questions. Can the protective relay prevent the fault? If yes or no, then what they are supposed to do. So these are the two questions which need to be answered. From this above discussion, we can see that faults can, protective relay cannot prevent fault. That is, it cannot prevent fault. And to a certain extent, fault can be prevented by properly designed and maintained equipment. Properly designed and the maintained equipment. And however, it is not possible to totally prevent fault. That is not possible totally prevent fault. Now the question arises that what the protective relay are supposed to do. These are supposed to detect the fault. These are supposed to detect the fault through the CT and PT. These detect the fault, CT and PT, with the help of and selectively remove only the faulty part from the rest of the system by tripping an appropriate number of circuit breakers. Also, the relay must have to do this with utmost sensitivity, selectivity, and speed. Sensitivity, selectivity, and speed. That is what it does. It removes only the faulty part of the system from the rest of the system. Let us suppose that we have a system and fault occurs in that part. So the relay will trip the circuit breaker in that part only, and it will remove only the faulty part from the rest of the system while tripping the appropriate number of circuit breakers. And it must be sensitive, selective, and speed is there. However, in the power system, the faults are not everyday occurrence. In a power system, the faults it is not everyday occurrence. However, a relay spends all the time monitoring the power system. It spends all its life in monitoring the power system, and it must therefore be ready all the time in anticipation of the fault. And it is said that the relay operates for more number of times during the testing and maintenance. Testing and maintenance. That is, it is said that the relay operates for more number of times during the testing and maintenance than during actual fault. So, during testing and maintenance, it will operate for more number of time. However, it will continuously monitor the power system in the anticipation of the fault. It will monitor the power system in the anticipation of the fault. So we can say that relay is an insurance against the damage due to the faults. So relay is actually it is insurance against the damage due to the faults. So this is all about this lecture. Today we have discussed some part of the shunt fault. Then we have discussed in the shunt fault we discussed that what are the characteristics which we have to take into consideration while seeing that fault has occurred or not. And in that way case we'll see that there is increase in the current and the substantial decrease in the voltage. And these characteristics we can see use for designing the system in such a way that it can detect. Next, we also see that the series fault. What are the series fault? In the series faults, we have the breakdown in the path of the current. However, they are not so drastic. However, in sometimes if the wire can touch the ground, then it may affect. However, we have also discussed that most of the open conductor faults sooner or later will develop into the short circuit faults. However, some of the open conductor faults are very I think it's very much drastic, like when the secondary of the current transformer and the DC machine, field winding of the DC machine is open circuited. After that, we have discussed the abnormal operating condition. We'll see that there is a very crisp boundary between the normal and the faulty conditions. So we have to take into considerations. That is, abnormal operating conditions are there, like we have the inrush current of transformer, then we have starting current of the induction motor, and then the power swing. So the relay must differentiate. Then we have discussed that whether that protective relay trip during the abnormal operating conditions, though the fault current at that very time is so much that it will qualify as a fault, but there must be such thing that the logic must be there that this relay must differentiate between the normal operating conditions and the abnormal operating conditions. Next, we discuss can the protective relay prevent the fault? It cannot prevent the fault. However, to a certain extent, the fault can be prevented by the properly designed and the maintained equipment. However, it is not possible to totally prevent the occurrence of the fault. So then we see that what the protective relay is supposed to do. The protective relay detect the fault with the help of the current and the voltage transformer and selectively remove that part only, faulty part, from the rest of the system while tripping an appropriate number of circuit breakers. So this is the relay. So the relay has to do this with the utmost selectivity, sensitivity, and the speed. So, however, we have also seen that it's discussed that in power system the faults are not an everyday occurrence. A typical relay spends all its life in monitoring the power system in the anticipation of the faults. Also, it is said that during operation, that is during the testing and the maintenance, a relay operates for more number of times than actual fault. So, a relay is actually the insurance against the damage due to the fault. So this is all about this lecture. In the next lecture, we will start with the evolution of the power system. Thank you very much.